So here, our aim to calculate the limit when x approaching 2 from left side. So x2 is this point. The means approach from left side, because of this minus sign, we understand left side. We should approach from left side of the 2. Okay. So what is the function value? At that point, the function value is 1. At that point, function value is again 1. So we approach step by steps 2. Okay. And we always found the 1 value. So when x approaching the 2 from left side, this limit is 1. Okay. In the second case, we approach the 2 from right side. So let's approach from right side. Here, the function value is 3. Okay. Here the function value is 3. Here the function value is 3. So when we approach the 2, the function value always approach to value 2. Okay, 3, sorry. So here the answer is 3. For the limit, if left approximation or left side approximation of the limit point and the right side approximation of the limit point are the same, we can conclude limit exists. Otherwise, we say the limit does not exist. So here, the limit does not exist since limit when x approaching 2 from left hand side f of x equals 1 and limit when x approaching 2 from right hand side f of x equals 3. And since these are different, limit does not exist. What is the f of 2? F of 2 value can be calculated by observing the value. Okay, so here this is blank. This is blank means it is not included. Okay, in the graph, it is not included. So here it is included. So this is our function value. When x equals 2, this is not included, so I'm go in that direction. So this is the function value of the f of 2. So f of 2 is 3. Okay, here f of 2 is 3 is the answer. I have a lot of questions about that one, but is there any problem here? Is there any point which is not clear? Okay, let's look this question. Here we discussed the limit at the point 3 from left side first of all. So where is our point 3? 3 is here. Let's approach the 3 from left side. Okay, so at that point the function value is this one. At that point the function value is that one. Let's make observation. This is the function value. This is new function value. When we approach the 3 from left side, this is another function value. So the function value approach to point 2. Okay, we can observe. So this is 2. From right hand side, here right hand side asked. Okay, so here the function value is this one. At that point the function value is that one. By this way we approach to 3 from right hand side. Okay, okay, so for example at that point this is the that value, this one. So you can you observe that one again is approach to 2 from down. Actually this is approached again from 2. Okay, but maybe we can say that by using another notation I will show that f of x, here f of x approach 2 from up. Okay, so bigger part. So f of x approach 2 from right hand side when x approaching 3 from left side. Here is extra information, but that's sketching the graph in the future you will need. Here f of x approach to 2 from down, from the negative side, less than the 2. Okay, so this is not negative maybe, but the less than 2 means when x approaching 3 from right hand side. These are extra information. But anyway, to calculate the limit of the f of x when x approaching 3, we should look to left side and right side. Not the approximation side is not important from right or left. It's not important. But here, this value are important. Since these are the same, limit of the f of x when x approaching 3 equals 2. Okay. And what is f of 3? Let's look the graph. F of 3 is not definite, because it's not included by the graph. Okay, so there is no function value. There is no point. If you consider the vertical line x equal to 3, there is no point. So this is not definite. Okay, the function is not definite at the point x equal to 3 is the answer. Let's look these two examples all together. In the first example, limit does not exist, but function value definite. Okay, function definite at the point 2, but limit does not exist at the point 2. In the second example, although limit of f of x when x approaching 3 exists, the function is not definite at the point x equal to 3. Okay, so this is the these are the two important examples for us. So there is no relation being definite and existing a derivative. Okay, there is no relation between them. If these are the same value, next week you will see it is called a continuous at that point, but it is the another definition.